Okay, let us discuss the next problem. This problem is again Eurodo from 5.15. So let us draw the figure first and then we will discuss the problem. So you draw the figure first. So you draw the figure first and then we will discuss the. Okay, let us discuss what this problem says. So this problem says at what angle of incidence theta 1 the light is reflected from the surface of water becomes perpendicular to the light of refracted. So this means what this question says, I have an incidence that has a refractive index unit 1. So in this case medium 1 refractive index is 1. So refractive index for medium 1 is 1 and refractive index for medium 2 is 2. This is given in the problem. Now let us say there is an incident ray. If this incident ray is coming here, it will be some light ray gets reflected and some light ray get refracted. So the question says what will be the theta 1 so that the reflected and reflected ray gets perpendicular to each other. Reflected and refracted ray. So this ray and this ray gets perpendicular to each other. So things are very simple. This means these two rays are perpendicular. So this means this angle is 90 degree. So if this angle is 90 degree, what will be this angle? You see, this angle is theta 1. So this angle is theta 1 because law of reflection. So if this angle is theta 1, so this angle will be, so this total angle is pi 180 degree. So 180 degree minus 90 minus theta 1 is this angle. So this means 180 degree minus 90. So this is 90 plus theta. This is 90 plus theta 1. So minus 90 plus theta 1. This angle is 90 minus theta 1. So this angle is 90 minus theta 1. This angle. Now apply the Snell's law here. So n1 sin theta. N1 is 1 into sin theta 1. So sin theta 1 is equals to N2. In this medium refractive index is N2. And sin theta R, that is the sin 90 minus theta 1. Refractive index is N. So you will have sin theta 1 is equals to N cos theta 1. Sin 90 minus theta is equals to cos theta. So this will give you tan theta 1 is equals to N. So theta 1 is simply tan inverse N. So you see, if the refractive index is N, I can find theta 1. So this is simply theta 1 is equals to tan inverse mu. If we write N is equals to mu. So you see, this is the sufficient condition that the theta 1 is equals to tan inverse mu when the two light rays, refracted as well as reflected ray, becomes perpendicular to each other. I think you have something like of angle of friction, tan inverse lambda, or in the friction of coefficient is mu, I don't remember exactly. Or if friction of coefficient is mu, then angle of friction becomes tan inverse mu, as I think. So angle of friction is defined as, let me try. So if I have a friction force acting in this direction, that is mu n. Normal reaction acting in this direction is n. So let us say if I define this angle as theta. So let us say if I define what is the resultant that is making, so let me define this angle as theta. So I will have tan inverse 1 by mu, but let us define this angle as theta from vertical. So if we define this angle as theta, so this angle will be theta. So I can write tan theta is what? Mu n divided by n. So I can write tan theta as mu. So theta inverse, so you can write theta is tan inverse mu. So this is the also called angle of friction. So angle of friction, if we measure from the vertical, this is generally measured from the vertical. So angle of friction is the same value, tan inverse mu, and you have the same value here. So angle of friction, so this is the analogy. Angle of friction is equals to tan inverse mu. Now here you see angle of friction is same as if you have a right ray, reflected ray and refracted ray becomes perpendicular to each other. You have the refractive index mu, that is the same theta 1 is given by same equation. So the angle of incidence is same as angle of friction, you see. If the refractive index and friction coefficients are equal, I can say if this mu and this mu are equal, if this mu or this mu are equal, so angle of friction and angle of incidence becomes equal. So analogically you can say something like this. These two situations give the same value of tan theta if the refractive index and friction coefficient are equal, because both is tan inverse mu. In one case mu is friction coefficient, in another case mu is refractive index. So this is an important observation. So we'll discuss the next problem. If you have not written everything, you just let us copy this one. We'll discuss the next problem.